This video is going to cover pages 26 through 27, which has to do all with right triangles. The two things that you absolutely need to know for right triangles are the Pythagorean theorem and SOHCAHTOA. So if you look on your formula sheet, the front page looks like this with all the formulas of the shapes. But if you go to the second page, the back side, you will see that there is a section dedicated all to right triangles. What you should write here is SOHCAHTOA like this. You should write it like this because it's going to help you use the formulas. It's going to help you know opposite, adjacent, and hypotenuse. So whenever I go back here, we're going to use some of these formulas. It's very good to know the special right triangles, especially since they're going to be on the SAT. These boxes right here will give you some time, and if you'd like to know more about how to use them, please ask me in class. So the first problem, again, these are all right triangles, so we're either going to use SOHCAHTOA or the Pythagorean theorem. The first problem says a 25-foot ladder, so they give us a picture. So right here I'm going to write 25. So then he gets the side of a building. The ladder is 7 feet from the building. So that's how far away it is, the base of the ladder. How far from the ground is the point at which the ladder touches the building? So whenever we're given two sides, we want to use the Pythagorean theorem. We only use SOHCAHTOA whenever we have another angle somewhere in our problem. So let's see here. It doesn't really show it too well on that page right there. But right here, do you see how we have an angle? That's what this is right here. It's a Greek letter theta. We're not given any angle besides 90 degrees on here, so it's not a candidate for SOHCAHTOA. So to solve this, we do a squared plus b squared equals c squared. So we have 7 squared plus x squared equals 25 squared. So whenever I solve this, I get 49 plus x squared is equal to 625. And I subtract 49 from each side. So I get x squared is equal to 576. So a lot of you might be tempted to stop at 576, but remember, I get rid of the square by taking the square root. So my final answer is x is equal to 24, that's feet. So problem number 2 says a utility pole breaks and falls as shown. So our whole pole is this size right here. What was the original height of the pole? So in order to find that, I have to find x. And actually, I'm going to call it y in this problem. I'm going to call it y because it's not my final answer. My final answer is going to be x, which is going to be whatever I get for y plus 5. Remember, I'm adding these two together. I'm finding the original height of the pole. So to find y, I have to use the Pythagorean theorem. My legs, or the short sides, are 5 squared plus 12 squared. That equals y squared. 5 squared plus 12 squared is 169. Again, to solve for y, I need to take the square root. So y is 13. Now I'm ready to solve for the original height of the pole. It's 13 plus 5, which is 18. So number 3 asks us to find the perimeter of the triangle. So again, the perimeters, whenever I add up, I need to find the perimeter of the rectangle, Perimeter of rectangles whenever I add up all 4 sides. So I know because it's a rectangle that the opposite sides are equal. And I'm going to put y again because y is not my final answer. I'm trying to find the perimeter. So my final answer, which I'll call x, is going to be 2y plus 2 times 12. I got this formula. You should know it just from doing so many other things. But I got it from the front page right here. Perimeter is 2L plus 2W. So whenever I solve for y, I'm going to have 12 squared plus y squared is equal to 20 squared. So 144 plus y squared is equal to 400. When I subtract 144, I get 256. Again, square root it, y is 16. So whenever I solve for y, two times 16 plus 2 times 12, if you punch that into your calculator, you will get 56. That's the perimeter of the triangle. So let's take a look at number 4. It says the escalator of the at the Metro Rail station in Los Angeles rises 76 feet at an angle of 30 degrees as shown. What is the distance d a person travels on the escalator stairs? So I don't even really need to read this. I just need to solve for d. So from 30 degrees, I see that this is the opposite side and d is the hypotenuse. So I erased it, but I have SOHCAHTOA. I'm going to write it again because it's so important. So remember, right here is where I should be writing SOHCAHTOA. So which one has O and H? That would be sine. So I set it up like this. Remember, theta is the angle. So whenever I go back to this problem, I'm going to say the sine of 30 degrees is equal to 76 over d. Whenever our variable is in the denominator, we switch these values around. This is a basic Algebra 1 trick that I hope you all know. So d is going to be equal to 76 over sine 30. And whenever I use my calculator, I will get an answer of 152. So let's do number 5. This is the last problem for this section. Again, we're looking for x. I don't even really need to read the problem because I'm given this right here. This one's kind of tricky, so I think if this was a problem, they would give you a picture like this. I can't solve for x alone, but I can solve for y. And y, I should say x, screwing it up a little bit. So we have x plus 26 is equal to y. So x is going to be equal to y minus 26. So y is the hypotenuse and 30 is the opposite. It's the same trig function as before. So the sine of 45 degrees is equal to 30 over y. So I get y is equal to the sine of 45 over, sorry, it's 30 over the sine of 45. Sorry about that. Remember, we switch these two around whenever our variable is in the denominator. So it's 30 over the sine of 45 degrees. So we get y is equal to about 42.4. Then when I plug that in, I get x is equal to 42.4 minus 26, giving me a final answer of 16.4. So that's it for right triangles. Please do those other problems on your own and ask me any other questions you have about right triangles.